So cosecant is 1 over sine. Now back when we were talking about unit circles, and we said cosine was which coordinate?
Cosine.
Yeah, it was which coordinate?
All students take calculus.
X. Yeah. And then the sine on a unit circle was which coordinate?
Y.
Y. What about tangent?
X over Y.
Other way. Tangent was y over x. So, tangent can also be written as, instead of y over x, since the y coordinate is sine, and the x coordinate is cosine, tangent could also be written as sine over cosine. They're equivalent. So if you took the tangent of 30, and then you took the sine of 30 and divided by the cosine of 30, you'd get the exact same thing. And since the cotangent is the reciprocal of that, for here, I could just flip-flop sine and cosine. So it would be cosine of theta over the sine of theta. Yes, these 7 you will have to remember. All the other ones I'm not going to make you, but these are used enough that you need to know. So first, on number 5, we're going to figure this out using that table we did yesterday. We figured out the cosine of 30. So look on that table from yesterday and tell me what the cosine of 30 degrees is. Okay? Square root of 3 over 2.
Where's your 30?
I'm just picking a number. I'm going to make it work. So notice how the way it's written is it's got cosine and then the squared and then the angle instead of the cosine of the angle like I wrote cosine of 30 and then squared.
So we
that
really
means
don't be needing no circles.
Circles. You mean theta?
Yeah.
Yes, we will.
So like this gonna be where we have to have it in the equation.
You'll need it because it can be whatever angle. All right. So, for example, what I was trying to tell you was that if you have that squared, that means the same thing as that. It's just mathematicians are lazy, and writing these parentheses are 2 more things that we don't want to have to write. So if we put the squared here, then I don't have to put parentheses around it. So what it means is you take the cosine first and then you square it. So we are going to figure out what this is equal to by doing an example, which you just looked at the table and you found out that cosine of 30 was square root of 3 over 2.
Also then it'd be square root.
So I'm just replacing cosine of 30 with what it's equal to. You got it from the table we did yesterday. What's the sine of 30? 1 half. To square a fraction, you just square the top and the bottom. So the square root of 3 squared. 3.
6.
2 squared.
4.
1 squared.
21, that's not
Yeah. And 2 squared. 4. So what's 3/4 plus 1/4? 1. Be 4/4. Yep. So this is the trig identity you need to know. You can do that with any angle. Cosine squared plus sine squared equals 1, always.
And this what most of them are going to have to be like.
You'll see what it looks like. Sine squared plus cosine squared, it could be written like that. It's addition, so it doesn't matter what order it's in. So just be prepared that it could be written the other way. Also, sometimes sometimes you'll see it where cosine is maybe all by itself. So like cosine squared of theta would be equal to 1 minus sine squared theta, just where we subtracted sine squared on both sides. Or you might see sine squared theta. What would that be equal to? How can I solve this equation, this purple equation for sine squared? Yep. So you don't have to memorize those other two that I've written because you can figure them out from the purple one. Now this comes from the Pythagorean Theorem. You can kind of see it. Something squared plus something squared. But you're going to see exactly where it comes from. So we're going to say this is our unit circle. So I know, oops, did not mean to do that. So I know if it's a unit circle, that the radius is always 1. And I know this is X and this is Y to get to this point. And I know normally to do this Pythagorean theorem, I would say, oh, X squared plus Y squared equals 1 squared. That's A squared plus B squared equals C squared. But in a unit circle, X is the same thing as the cosine of whatever this angle is. And Y is the sine of whatever that angle is. So this is where that comes from. Comes from the Pythagorean Theorem. So these are called the Pythagorean Identities, the next 3. This one and the bottom 2.
It's called what now?
The Pythagorean Identities. Just because they come from the Pythagorean Theorem. It's just not something we made up, basically. I'm showing you where it came from. Again, this next theorem you need to know. Like I said, all 7. Next identity you need to know. We are going to verify it by rewriting both sides in terms of sine and cosine. By verifying it, we're going to make the left side look like the right side. Anybody still using number 5? All right. So according to, I guess it's number 1 up there, I can rewrite tangent squared how using cosines and sines. Tangent is equal to what? Look at number 1.
1 over cotangent.
And? So, sine over cosine. And then what was secant equal to up there?
Where did you get sine over cosine?
So what's secant equal to if you look up there?
Cosine.
1 over cosine. Yeah. Now how do you square a fraction? How did we square these fractions?
Just do the top.
Yep, square the top and the bottom. So I have 1 plus sine squared theta over cosine squared theta. What's 1 squared? 1 over cosine squared theta. So what I'm wanting is these two to equal each other. Just verifying that that's a true statement.